Now let's move to the question number 7. Express 6 sine theta minus 4 cos theta in the form of r sine theta minus alpha, where r is greater than 0 and alpha is less than 90 and greater than 0. Give the exact value of r and the value of alpha correct to the two decimal value. Okay, we need to find the r sine theta minus alpha. So r sine theta minus alpha. When we apply sine theta minus alpha, so we know that sine A minus B is equals to the sine A cos B minus cos A sine B. So this one is equals to, by applying this identity, we will have r sine of theta cos of alpha minus cos of theta sine of alpha. And this one is equals to r cos of alpha sine of theta minus r sine of alpha cos of theta. And we need to express this in the form of this. So we compare this value with this. So 6 sine of theta minus 4 cos of theta. So you can see that this one is and this one is equal to 6. So r cos of alpha is 6 and r sine of alpha is 4. And we need to find the value of r and alpha. Okay, when we square both equation 1 and equation 2, so r square cos of square alpha is equals to the 36, because 6 squared is 36. Similarly, on the other side, r square sine of alpha square is equal to 16. Now we add them, we will have r square cos square alpha plus r square sine square alpha is equals to 36 plus 16. So we will have r square common, and cos square alpha plus sine square alpha is equals to the 52. And we know that sine square alpha plus cos square alpha is equals to 1. So r square times 1 is equals to 52. R square is 52. So r is equal to under root 52, or we can say that 4 under root 30. So we have calculated the r and we need to find the value of alpha. So plug this r value in equation 1. We will have r cos of alpha is 6. So r is under root 52. Cos of alpha is 6. So cos of alpha is 6 over under root 52. So for 6 over under root 52 is equals to the 0.8320. So alpha is equal to cos inverse of 0.8320, and alpha is equal to 33.690067. So we can say that 6 sin x minus 4, 6 sine of theta minus 4 cos of theta is equal to r sine of theta minus alpha, and in this case r is under root 52 and sine of theta minus 33.69. So 6 sine of theta minus 4 cos of theta. So we have achieved the required form. Now let's move to the part B. Unsolve the equation 6 sine theta minus 4 cos theta plus 5. So we have just calculated this in the form of r sine of theta minus alpha, which was under root 52 sine of theta minus 33.69. And we need to solve this equation for the value of theta less than 360 and greater than 0. So we can write it under root 52 sine of theta minus 33.69 plus 5 equal to 0. Okay, when we switch positive 5 on the right side, we will have sine of theta minus 33.69 equals to negative 5, and here is 52 under 52. So sine of theta minus 33.69 is equals to negative 5 over under root 52. So we need to find the theta. Okay, in this case, the given range of the theta is include all the range. So we find the base angle first. So we take positive. So theta minus 33.69 is equal to sine inverse of negative or positive 5 over under root 52 base angle. So theta minus 33.69 is equals to the sine inverse of 5 over under root 52 is 43.8978. Okay, this one is negative value. So sine is negative in fourth quadrant and third quadrant. So we need to find the angle in third and fourth quadrant. So in fourth quadrant we can find angle negative theta. So first angle is theta minus 33.69 equals to negative 43.8978, and in third quadrant we will have negative 180 minus theta. So theta minus 33.69 is equals to negative 180 minus 43.8978, and this negative angle can be written as theta minus 33.69 is equals to 360 minus 43.8978, and this one is equals to the 316.10. And on the other side, theta minus 33.69 is equals to the, so this one is negative 136.1022, and when we add to 360 minus 136.1, so this will be equals to the 223.8978. So theta minus 33.69. So we can say that sine inverse of negative 5 over under root 552 has two angles, this one and this one. Now for the angle, theta is 316.10 plus, when we switch negative 33.69 on the right side, it will be positive, and this one is equals to the 349.79, and in this case theta is equal to 223.8978 plus 33.69, and this one is equal to the 257.58. So we have 2 theta this one, and theta is. Now let's move to the part C. As the value of beta varies, find the greatest possible value of this expression and determine the smallest possible value of beta in degree for which this greatest value occurs. Okay, from part A, 6 sine of theta minus 4 cos of theta is equals to the under root 52 sine of theta minus 33.69. and here it is 3 and 2, so we take common. So this will be 3 sine of theta minus 2 cos of, and under root 52 can be written as 2 under root 13, and this one is equal to sine of theta minus 33.6. So 2 will be cancelled out, and this expression 3 sine of theta minus 2 cos of theta is equal to under root 13 sine of theta minus 33.6. So in place of theta, we will plug 4 beta. So here 3 sine of 4 beta minus 2 cos of 4 beta is equal to under root 13 sine of 4 beta minus 33.69. Okay. So when we use this equation here, so we will have 3 sine of 4 beta minus 2 cos of 4 beta whole square plus 15 is equal to the under root 13 sine of 4 beta minus 33.69 whole square plus 15. And we need to find the maximum value of this expression. Max of under root 13 square is 13, and sine of sine square is sine square. Sine square of 4 beta minus 33.69 plus 15. We need to find the maximum value of this expression. So maximum value of this expression can be achieved if we find maximum value of function. If we find the maximum value of sine, we can find the maximum value of this expression. So maximum value of sine is sine of x is less than and equal to 1 and greater than and equal to -1. So sine square will have maximum value greater than 1 and less than 0. So we can say that maximum value of this expression will be when sine square of x is 1 for maximum expression. So we can say that 13 times 1 plus 15 is equal to 28. So maximum value is 28. To achieve maximum value, we need to find the minimum value of beta. So sine square of 4 beta minus 33.69 is equal to 1, and this one is equal to sine of 4 beta minus 33.69 equals to 1. So 4 beta is minus 33.69 is equal to sine inverse of 1. Now we need to find the smallest possible value of beta in degree. So smallest value of sine inverse of 1 is 90 degree. So we can say that 4 beta minus 33.69 is equal to 90 degree, and 4 beta is equals to 90 plus 33.69, and beta is equals to the 19 plus 33.69 over 4. So this is the minimum value of beta for which we can achieve maximum value of this expression, which is 28. This is the minimum value of beta.